gonna teach you how to make your operating system, and this is the part 1. Before going further, I wanna tell you a news. Thank you for 28 subscribers, and the target is 1000. And if I get 2 more subscribers, and if this video gets 100 views, then I'll make part 2. So without wasting any time, let's go further. So we all know about these knowledges, but there are 2 knowledges, but there are many things to understand. So we all understand this term. An operating system is a system software that manages computer, hardware, and software resources and provides common services for computer programs. For example, here I am drawing a box. Imagine you're a messenger. So the user sends a request to you. It can be related to hardware, software, or anything else, which can they read in their language you're choosing. And when we click, you translate that language into your language, and then process it to the hardware, even more complicated. And then the hardware sends the output to you, and then you transfer the output to the user. This is how it works, and this is how I learned from OSDev. Then tell me. Okay, enough scripts. So the second term of it is low-level languages, commonly assembly. This is the language ever I've heard of. It uses meaningless instructions like move, one. I don't even understand. I'm a teenager and I don't even understand what the heck is this. So this is why I'm gonna use Grub, and you just need to follow download the template and then do all the C code. So you don't need which your C++ is used to write the operating system code. Another thing is bootloader is a program which loads the kernel after the computer turns on. So there is one thing I forgot to include, that after BIOS check. After BIOS check succeed, you can see it as a scribble or something. After BIOS all checks succeed, bootloader is a program which loads the kernel after the computer turns on. We're gonna use grub. We're gonna use grub, the T-Rank bootloader. So and then kernel is a central component of the OS that manages the operation of the computer hardware. 1 and 4 are really related to each other. They are related to each other. In the example I've given you previously. So now we need to understand 2 and 3. 2 and 3 are left that we need to understand. So let's go back. Let's erase all the scribbles. Wait a minute. What the heck? So you can see this chart. You can see this chart. So hardware, machine language and assembly language. Assembly is the language written in machine language, which is known as binary. Zeros and ones. And then assembly languages convert them to machine language. And then high level languages are supported. These are Fortran, C, Pascal. Sorry, I need a break. So sorry for the noises I made previously. So where was I? So Fortran, C and Pascal. These are high level languages and assembly and machine language. So assembly is structurally written language. Oh no, these bastards have come again. Sorry again for that. So finally got rid of those goosebumps. So high level language, these are Fortran, C and Pascal. Put their here again. Get out. So after that, high level language. They're high level language. So assembly is structured and machine language is the binary. And these are all combined is equals to an operating system or an OS. And they interact with hardware. And in these things, we have the kernel inside of it. So kernel is like a seed, and the rest of it is the trees. So now let's see the requirements. Cross-compiler setup is in the description. And 64-bit computer with SSD. SSD is recommended for hardware is hard HDD. I like HDD, but SSD is recommended for making the cross-compiler setup faster. It takes about 4 to 5 hours. And Linux-based environment. In my case, I am gonna use WSL, Ubuntu, Mac users, homebrew or a virtual machine, and CPU core is 4, in my case, 4 or higher. So building. Now let's get building. So we got rid of those goosebumps, gooseworms. So I've cd'd into my directory, and you wanna go to github.com /ofstef-guide, and then it will download the setup file and the part 1 file. So I've copied in and git clone dash guy. Get up to fear. So let's cd into it. ls. So cd setup ls kmod plus x setup.sh. So I've already installed the things, but let me explore it for you a bit. The fucking errors again. So it will install Nazem, QEMU, KVM, grabpc, grabcommon, and Zoriso. And grab to Zoriso are the ISA building things, and Nazem, QEMU, KVM are Nazem is the assembly compiler, and the QEMU is the, what should I call it? Is the virtual machine. So and then it will install the dependencies. So one thing I want to note is sudo get install lib. This is optional, but it will help you. So now in my case it's already installed, so let's cd back to it and cd. But now you'll see some goosegumps, which are SSE and targets. So let's see the SRC a little bit. So these are goosebumps. We'll talk later. So now we'll run make, and then make build 86_64. So now when we ls, we'll get two more things: the dist and the build. The build contains the output files, and the dist contains the ISO files. So now let's cd into dist. ls QEMU x86_64. Wait a minute. Yeah, that should be correct. Kernel.iso. So it should show grab, and it will take some time, and then hooray, our kernel is loaded, and you'll see some things: blue background, yellow background, not big enough, but instead of it, the text. Now if you wish, you can go out, cancel it here. But if you want to explore, then you should. Then let me tell you that this is a template. So the SRC contains the things, and the targets do not do anything here, okay? Unless I got it. So let's say the SSC, the targets. So let's go to SSC. You might wanna, so after seeing the code, you might wanna say, so this is the main.c. we're not gonna use the GNU official kernel main print clip. Here, welcome to our 64-bit kernel. Here is the print.c file and the intf. The intf means the include. Here we have the print.h file. Let us see what's in here. So we have these standard headers with the headerless cross compiler without the stdios. That is called headerless. They should. And then there is the color ID. So let us do an experiment. So we're gonna give the background light green and the text color will be the same. So let's do that, please. Print that. Who got this? I know it's tough, but these will mean helpful later. So this will be the same. Let's change the So now let's remove. I'll include the clean. Shit, I suck. So you need to do 2 folders. Make of make build x86 underscore 64. So this is a type of command. I means include /intf. So now you're free from confusion. So now let's run it. Oh shit. This cd start ls. Now finally we can cameo. So you might see an error message here. Yes, this is the error message, but the output is correct. So we don't care about the error message, we'll care about it later. So what's the conclusion? So what we did is already implemented in my repository, and you want to start this thing, a file system and VGA support, and here is this. So see ya, and make sure to like, subscribe. Thanks for watching. See you next video.